So then there's quantum networking. This is sometimes called entanglement-based networks or entanglement networks. So these are quantum networks that generate quantum entanglement. That entanglement can be used to do key exchange. So it can be used to do entanglement-based quantum key distribution, but it also unlocks other use cases. So this entanglement can be used to connect quantum computers together. It can also be used to connect quantum sensors together and unlock other applications. So it's not just a single purpose QKD network, it can be used for other things. The key difference that I want to make clear between entanglement-based networks and QKD networks is that there is no trusted relay node requirement for quantum networks. And what that means is that, going back to that distance limitation I was talking about, for QKD networks, it's a requirement that to get beyond that point-to-point distance limitation, we're going to need what's called a trusted relay node. So that relay node needs to be trusted because the key material is actually going to be exposed in the clear at that node. So it needs to be trusted that that information will not leak. So that's obviously a big security concern. With entanglement-based networks, that's no longer the case. We do not need any trusted relay nodes. And the reason for that is that there's no classical key material until the entanglement has been generated and distributed to the two parties that want to communicate. So a quantum network will use what are called quantum repeaters to kind of extend and generate entanglement between two parties. And once that entanglement is generated end-to-end, then we can measure that entanglement and produce key material. But the key material is never exposed at any intermediate node along the way. That's a key difference between quantum networks and QKD networks, is that quantum networks sort of address this elephant in the room of the trusted relay node requirement. So how would this work? How would a quantum network integrate with your classical infrastructure? So let's take a look at what is done today. So most modern networks use this hybrid crypto system that I was talking about earlier, where they will use asymmetric encryption, so protocols like RSA and Diffie-Hellman, to do the key exchange. And then they will use symmetric encryption, like AES, to do the actual bulk encryption and decryption, the actual communication between the two parties. So this is how a quantum network and quantum key exchange would integrate with the system. So we're not, the good thing about this is that you don't have to rip and replace the whole internet or the whole existing communication infrastructure. All we're replacing is that key exchange part. That initial step of generating and sharing that secret key is now replaced with a quantum network. So a quantum network will be able to generate and distribute entanglement between these two parties. That entanglement can then be used to produce secure secret keys. But those keys can just be passed up to the legacy classical encryptors and decryptors that we use today. So we don't need to replace the bulk encryption hardware that we use already. Once we have those keys, we can create a session and just communicate like we do today. We're just replacing that initial key establishment part. Longer term, we can expect that quantum networking and quantum key distribution can be used to secure things like SD-WAN from attacks by quantum computers. Another thing I'd like to mention is that these solutions, PQC, QKD, and entanglement-based protocols, are actually all interoperable with each other. And this is a good way to sort of diversify your trust in these different protocols. So key material can actually be drawn from different algorithms, different protocols, from PQC, from QKD, or from an entanglement-based approach. And the reason that's promising is because your encryption is as secure, it's as good as your strongest protocol. So any adversary would have to break all of them to capture the key. And this is good because, QKD or an entanglement-based approach may not be feasible for any two nodes on the planet, right? So we can leverage other protocols as well, and have this sort of hybrid approach, or what I like to call defense in depth.